Welcome to our
Welcome to my YouTube channel, everybody. Okay, so this is again section 2.5. We're going to spend 2 days on this section. I will tell you this right now. There are some of you that are going to be like, your minds are going to be blown by this today. Like, so there are going to be some of you that walk out here and be like, well, I thought I knew what I was doing, right? That's why we're going to, this is a good thing this is going to happen over the weekend, because it just kind of needs a little time to marinate in your brain a little bit, okay? This is when we really start to get into a little bit more of the abstract side of algebra. What I mean by that, I mean like no numbers, only letters. Okay? No actual numerical values, only variables. Okay? Only things that could possibly change as represented by a letter. Okay? So it's a little bit harder conceptually, but we'll go through it and it'll be all right. Now, in science class, you guys work with a lot of formulas, right? A lot of well, I guess in math too. You got the area formula, you got the perimeter formula, you got, all different types of formulas. And throughout all of science, you're going to be, manipulating equations to try to get what you want out in the end, okay? Now, to manipulate equations, you're going to need to solve for different variables, okay? To manipulate the equations, you need to solve for different variables. So I am going to teach you these steps to solving these equations for different variables. If you just keep following the steps and plugging along, it will eventually click. Let me go with me here. This isn't in your guided notes, but I want to talk about this formula. Does anybody recognize this formula? D is equal to R times T. That's distance is equal to rate times time. Okay? Makes sense. Rate times the time will give you the distance traveled. So like if I'm traveling 50 miles per hour at 3 hours, I'm going to go 150 miles, right? If I am, that was rate times the amount of time, it's going to give me the total distance. But what if I said, okay, I know I want to get to my place in 4 hours, right? And I have 100 miles to travel. What do you do then? Does this equation still work? Well, kind of, right? We would have to plug it in and resolve. Or we could resolve first and then plug in. Like here, I know my distance and time, but I want to know my rate. How fast do I have to be to get there? So distance divided by the time would be equal to rate. Or if I knew my distance and I knew my rate, I've got 500 miles to travel and I'm traveling at a speed of 75 miles per hour. It's going to take me whatever that amount of time is, right? Distance divided by the rate will get you the amount of time that it will take to get there. So we have this equation that we could manipulate to get what we want out again, okay? That's really what we're doing here. We're manipulating the equation. So what are the steps to do so? First thing is you locate the variable that you're trying to solve for. Everybody look on your pages. Every one of these examples ends with for X, for Q, for T, for B, for Y. I have to tell you a variable to solve for, okay? That variable you're trying to get alone. Okay? You're trying to get that alone, you're trying to isolate that variable. So you locate it, then identify what's happening to it. Is it being added, subtracted, multiplied, divided? What's going on to it? And then the last step is basically use inverse operations like we've been doing this whole chapter. Use the inverse order of operations to solve for that variable. Get the variable you're solving for completely alone. So let's try one here. What variable am I solving for? X. So everybody find X, circle it. Don't move it. Tendency is to try to move the variable that you're solving for. Don't move it. What's being done to X? Added with Y, right? Y is being added to it. So how do I get X completely alone? What undoes the addition? Subtraction, right? Right, so the subtraction will undo the addition. So if I'm adding Y, obviously, then to solve, I would just subtract Y. Okay, well, the problem with this is that, can I take 15 minus y? Like, it won't become a singular number, will it? No, and that's okay. You're going to have just 15 minus y. Am I going to get x equals a number? No. That's not the point to these. The point is just to manipulate the equation. You're not actually getting x equals or y equals a number. Not for these ones. So how do you know when you're done? Because before it was like x equals 5, you're done, right? How do you know when you're done then? Well, the variable that you're solving for, the one that you circled at the beginning, should be completely alone. Once it is, now you're done. As long as the other side is fully simplified. And x is equal to 15 minus y. Let's do another one. Okay, I'm solving for q. So let's circle q. What's being done to q? Multiplied by p. So how do I get that? How do I undo that? Divide by p. Divide it to both sides. That's going to cancel it on the left side. It's going to undo it. And on the right side, can I simplify anything with x divided by p? No. It's literally just x divided by p. All we're doing is manipulating the equation. We're changing what the equation looks like. We're not actually getting q equals 5, q equals 3. No, we're not getting a number. We're just manipulating what it looks like. Okay, so what's being done to t? What's being done to t? Tatum? Okay. Oh, sorry. T. It's being multiplied by 2. So what undoes that? Divide by 2. Now here's the tricky part. If you've got more than two terms on the, or sorry, if you got more than one term, you've got two terms on the other side, and you're dividing by 2, each piece needs divided by 2. Each piece needs divided by 2. 6 needs divided by 2. 4 needs divided by 2. Okay, so we've got 3 minus 4 divided by 2, 2b is equal to t. Is t completely alone? Then we're done. Can I simplify the left side to make it 1b? No, they're not like terms. Leave it. Solve y equals abc for b. Okay, now, what happens when we've got more than one operation going on? Well, if it's the same operation just with two different things, we can actually do that to both things to get it to go away. Like, for example, here, what's being done to b? Multiplied by both a and c, right? So how do I undo that? Divide by both a and c at the same time. Because it's going to cancel it both on the right side, leaving only a b. And then on the other side, it's just simply y over ac. The tendency is to try to do more than you need to. Remember that once you get the variable completely alone, that's it. So here's where it starts to get a little bit more fun. My version of fun. Okay, 2x plus 3y is equal to 6. Guys, we're going to have these problems. We're going to do like a million of these once we get to like chapter, I think, 3 or 4. Because what you're seeing here is something called standard form of a line, where you have x, y, and then a number. And then if we solve for y, we're going to put it into this thing called slope-intercept form. Okay? We're going to put it in this thing called slope-intercept form, where we solve for y. So we're going to do this a little bit later on. So it's very important that you understand how to do this. Okay, so what's being done to y? added and multiplied, isn't it? There are actually two things being done to y. Multiplication and addition. Now, let me ask you a question. Let's do this. Let's say, what if I just replaced this all with numbers? Doesn't really matter. What would be the first thing that you would do to solve that equation in red? Almost everybody would tell me the right answer. What would I do first? Would I even think about dividing first? No, heck no. You wouldn't do that. You wouldn't want to do that because you need to do reverse order of operations. You want to undo all of your addition and subtraction first before you can work with your multiplication and division. The same rule applies, folks. So what should come first? Should I get the addition to go away or the multiplication? The addition. I need to subtract 2x first, just like I would subtract 4 first. Bring down what we don't use. 3y, circle. 6 minus 2x. Can I make that 4x? No. That's a very common mistake. That's why I keep bringing it up. You cannot combine those like terms. Well, they're not like terms. Okay, now what do we do? Emily? Everybody gets, you get divided by 3, you get divided by 3, you get divided by 3. So y is equal to, 6 divided by 3 is 2. Now, this last part here, you could make it 2/3 x. You're going to see me write this as 2x over 3. Either way is fine. When we get to the solving for equations of lines, I might change that into a fraction because that will become our slope. But there's my answer. Yeah? Like this? Are you talking about the 6 and the 2? Here? Yeah. We did that because 4 was actually divisible by 2. Like we could actually take 4 divided by 2. On the last one that we just did, 2 you can't divide by 3. If that's a simplified fraction. Does that make sense? Like we can't actually simplify that down. If you take 2 divided by 3, what happens? You get a decimal, right? 0.6 repeating. And that's a fully simplified fraction. If I took 4 divided by 2, I can actually do that. That's a 2, right? So when you can divide and it comes out nice and even, you can do that. If you divide, you get a decimal, you leave it as a fraction form. Okay, flip it over to the back. Now, the back is all word problems. Because this is where its application comes in. The formula for an object's final velocity. So this must be some sort of physics equation. The formula for an object's final velocity is F is equal to I minus GT, where I is the initial velocity, G is acceleration, and T is the time. For our purposes right now, do we really care what those mean? Not really. For our purposes, all I want to do is just solve for I. So what's being done to I? Being subtracted, right? What undoes subtraction? Addition. Now, do I want to break apart the G and the T? No, I want to move that all together as one. Is I completely alone? Yes. So I'm done. We'll stop there for today.
You're right. There was a lot to process.